Hello everyone, welcome back to e-learning. So today we're doing natural sciences and our focus is on acids, bases, and neutrals. Right, so let's look at acids and bases. In this section, you're going to know what acids and bases are like, how they feel and taste, and how to tell the difference between them. So if you look at this picture here, you can see at the central by number 7, it says neutral. So you can see that water is neutral. Now if you go to the right, you can think of it as a number line, but starting from 7. So if you go to the right, everything on the right, like the eggs, soap, bleach, baking soda, ammonia, and oven cleaner, they are all bases. If you go to the left, we have milk, tomatoes, bananas, grapes, lemon, and your stomach acids. These are all acids. Now we're going to learn the difference between a neutral, acids, and a base. But we're going to start with acids first. So you're going to ask yourself, what are acids and bases? Basically, they're two types of chemicals. They're found in household and in food products. And we can sort them and group them into acids and bases. So when we say sort and group, we mean categorize them. So acids are basically things like lemon juice, vinegar, and fizzy drinks, while bases are things like soap and cleaning products. Now you must know that the human tongue can actually taste whether something is an acid or base. So there's four tastes: salty, sweet, sour, and bitter. But not all say substances are actually safe to taste because some are very, very strong acids and some are very, very strong bases. So you can't always just taste because it's not safe to put anything into your mouth. But so here we have the uses of bases. You can see there's hydroperoxide, that's a soap. Detergents, a sodium bicarbonate. So baking soda, a sodium bicarbonate. Magnesium hydroxide is treating acidity. That means if you have too much acid in your stomach, you can take some enos. Then we have ammonia, which is found in fertilizers. Hydrogen hydroxide is found in calcium hydroxide is found in cement. We have sodium fluoride in toothpaste, and in labs, there's different types of bases that are used. Now, acids, you get vinegar, it is ethanoic acid. Um, fizzy drinks, you get carbonic acid. Tea is tannic acid. Vitamin C is ascorbic acid. And lemons, you get citric acid. So, this is basically things that you'd find at home, acids and bases. Now, acids, many foods such as vinegar, fruits, and sour milks contain acids, and your stomach produces hydrochloric acids, which helps you digest your food. But um, this is a strong acid. Now, the weak acids are citric acids, which is your citric foods, fruits, and lemon juice, ethanoic acid, which is in vinegar, lactic acid, which is sour milk, carbonic acid, which is found in fizzy drinks, and hydrochloric acid. I said that is a strong acid. Now, that is why you suffer from acid reflux because that is too much of acid in your body and it's not good for you. So, you need to have a balanced diet so you do not suffer from acid reflux. Now, uh, another strong acid is sulfuric acid. Now, that's found in batteries and in fertilizers and fireworks. Some weak acids are ethanoic acids and carbonic acid, which is found in vinegar and fizzy and cool drinks. Now, when we say strong acids, these are corrosive, which means that they can eat into clothing, stonework, metals, and actually burn your skin. Now, when you suffer from acid reflux, it has that burning feeling. So that is a strong acid. Now, when you want to identify um, household items with strong acids, they normally put these symbols on it. Here use is, here's a picture that means that it's corrosive, it can burn you. There's another picture with a skeleton. This means it is hazardous, it is a hazard, and this substance is toxic, so you cannot drink it, and when you're handling it, you must handle it with care. Now, properties of acids, basically acids. Now, instead of tasting it in your mouth to get that sour or bitter feeling, or what, to decide if it's an acid or a base, you use litmus paper. Now, in an acid, blue litmus paper turns to red. Now, properties of acids, they found in vinegar, fruit, sour milk, and your stomach acids. It tastes sour and it feels rough on your skin. It turns blue litmus paper to red. It has a pH that is less than 7, and it is corrosive and dangerous. Now, like acids, bases, and alkalines that can be strong and weak, we say that bases are caustic. This means when we say something is caustic, it means that um, it's just as strong as it is, just as an acid is corrosive, bases are caustic. Okay, so that means it can also eat through something. So strong bases are sodium hydroxide, which is your oven cleaner, potassium hydroxide, which is making soap, calcium hydroxide, which is an ingredient in mouthwash and making mortar and plaster. Weak bases is magnesium oxide, which is used to treat acid indigestion, and bicarbonate of soda, my apologies, which is used in baking. Right, properties of bases, they found in soap and cleaning agents. It's bitter. If you had to taste it, it's slippery and soapy. It turns red litmus paper to blue, like in the image I have on the right. Its pH is greater than 7, and it is caustic and dangerous. Okay, so here we're going to look at neutrals. Now, neutrals, it is neither acid nor a base. So when you use your litmus paper, it will not change its color. So neutrals are not dangerous. It's good for you. It's safe for you to drink it. Examples of it is pure water, cooking oil, and salt. And a neutral reacts to an acid or a base. So acids and bases can cancel each other to form a neutral substance. Like toothpaste contains weak bases that cancels out the acid in your stomach. Sorry, your acid in your mouth. This makes your mouth neutral. Now, remember I told you that you use litmus paper. So this is an acid and base indicator. So you use this to test whether a mixture is acid or a base. And it is safe instead of putting it into your mouth and causing problems. So litmus paper is made from lichens. Now, when you're doing the litmus paper test, you get blue litmus paper turns red, then you know it is acid. And red litmus paper will turn blue, then you will know it is a base. When it does not change color, then you know it is a neutral. Now, both red and blue litmus paper is to test unknown substances. Right, neutrals, they're not acidic or basic. Examples is water, salt solution, and cooking oil. Its pH is 7. It does not change its litmus paper, and it is the taste is mild or plain. So here is a mind map that you can use to study from, to check whether things that you know and you don't know, you can fill in missing information. I'm not doing it for you because I want you to learn. Now, part of this type of learning is called, gosh, it was at the tip of my tongue. It starts with C, and it's oh my word. Okay, so you are, oh, okay. It may be in one of my next videos I'm going to tell you, but it's something that you're going to use to constructivism. You're going to construct your own knowledge. So I'm going to try and leave you with that. Right, hope you liked my video. This is the last section for term 2 in natural sciences. Don't forget to like and subscribe, and hope you enjoy your learning. Have a good day. Bye, everyone.